The topic that we are going to discuss in today's session is a fun topic, one of my favorite topics. It's called magic squares. And I think some of you might have been introduced to a bit of something called as magic squares. Maybe others are a little new to it. So let me try to explain in simple words what is a magic square. The magic square, first of all, as the name suggests, it is made up of a square. Okay, it could be a 3 by 3, it could be a 4 by 4. 4 by 4 meaning there will be 4 cells in a row and 4 cells in the column as well. So total 16, or it could be a 5 by 5. Okay. So the grid is something like this. And in each of the cell, there has to be numbers. And the numbers should be such that if you take the total of numbers in any row or any column, okay, that is, if you take the total of the numbers in this column, or this column, or even the diagonals for that matter, okay,
Long
even
diagonal.
the diagonals, the total should be equal, okay, or I would say the same total. So if that happens, then this square is called a magic square. Okay. So suppose somebody tells you or asks you to create a magic square in 1 second. Can you create a magic square in 1 second? Yes, Saket. How do you do that?
So just put one
Just,
all squares. So put the one.
just put 1 in all squares, and then the total will be same, right? But then there is no fun in that because there is nothing challenging over here. So magic square, in a magic square, we generally try to keep all the numbers different from each other. Okay, so the numbers have to be distinct or different from each other.
Sir, I know how to do magic square.
Excellent. Okay. Can I know how many of you know how to make a 3 by 3 magic square? Can you do a raise hand so that I can know? All right. Okay. 1, 2, 3, 4, 5. All right. So Aitreya, can you tell me how do you make a 3 by 3 magic square?
Yes, sir. Sir,
Yeah.
take the second row, and at the
Mhm.
outer box, on the right side, make another box.
Okay. Something like this.
Yes, sir. Sir, and in the
Okay.
left also.
Okay.
Sir, and in the middle row,
Mhm.
the vertical one,
Mhm.
the vertical middle row, you can make
Like
another
this.
box, and down also.
Okay.
Sir, and we can write even or odd numbers.
Okay.
Like, suppose first diagonally, we can write diagonally, like at the left side box, outer box 1, and then at the topmost box 3.
Okay.
Not there,
Here.
at the corner. Yes, and then
Okay.
there 5,
5.
and then 7.
You mean 7 like this?
Not there, sir, not there. The down corner.
Okay.
Down.
7, 9,
No, sir,
11.
no, sir, not there. At the down corner, near
Oh
1.
God.
Near 1.
I'm really terrible. Okay. 7 like this.
Yes, sir.
Okay.
9, diagonally, and 11.
Okay.
And we can again start from the box, the outer box, down.
Like this. 13,
Yes, sir.
15, and 17. Okay.
Sir, and we have to interchange 1 and 17 and put inside the box.
You mean 17 will come here, something like
Yes,
this.
sir. And 1
Okay.
will come at this side.
And 1 will. So it will kind of.
Yes, sir. And then
Okay.
5 will come at the place where 13 should go, and 13 should
Okay.
go where 5 should.
Okay.
Sir, and if we add up diagonally, vertically, or horizontally, the sum will be the same.
Really? Let me try. 7, 5, 15, right? So let's add 3 plus 13 plus 11 is 27. 17 plus 1 plus 9 is 27. This is also 27. If I add diagonally 12, this is going to be 27 diagonally. 11 plus 1 plus 15 is 27. This is also 27, 27, and this is 27. Yay. So now we have a magic square whose total is, or we say the magic constant, okay? Magic constant, or it is also called the magic sum, okay? Magic constant or the magic sum is
Sir,
27. 1 second, I just 1 second. So the magic constant or magic sum is 27, right? And it is made up of all distinct numbers or different numbers, okay?
And it is always thrice the middle square.
Oh, says Darshraj, that the magic constant 27 or whatever that number will come is always 3 times the number in the central square. So 3 times 9 is 27. Okay,
Sir, how did
that's
we get
interesting.
sir, how did we get the other numbers like 3, 11, 9, 7, 15 in this method? Sir, can you explain again?
Yeah, so in her method, so there are multiple ways to construct magic square, okay? And this is one of the ways that we have seen, which Aitreya shared. That is, if you want to construct a 3 by 3 magic square, what we do is we put something like this, these 4 squares, and we write the numbers successively, 1, 3, 5, 7, 9, 11. So you can see they are successive odd numbers, 13, 15, and 17. We have written, what we have done is we have chosen 9 successive odd numbers and we have placed them in this manner. And after that, you just swap those 2 numbers which are outside, you see, in those boxes. That is a method that Aitreya suggested. Now, there are multiple ways to do
sir,
that.
and this only can be used in consecutive numbers.
So Aitreya is saying you can do this only with consecutive numbers. This will not work or may not work for non-consecutive numbers. Okay. So let me so thank you Aitreya for sharing
Sir,
this.
is there a proof? Is there a proof for this?
Yes. So let me just continue with some parts, and then after that I will open it to some questions and discussions. So one small comment is it need not be just for consecutive numbers. We can also bring in numbers that are not like this consecutive, where things work in a slightly different way, but we will get there. Okay. So before this, I just want to kind of give you one method, or rather one more method for constructing a 3 by 3 magic square. Okay. So a 3 by 3 magic, this is a 3 by 3 magic square. And let us say that I'm using the numbers 1 to 9. Okay, all natural numbers from 1 to 9 to construct this. Okay. And this method is, what is this method called? In Indian context or in Indian writings, we call this as Alpashruti. Sorry, not Anushruti, Alpashruti. Alpashruti. 1 second. Suraj, are you looking into the waiting room? I think somebody is in the waiting room since quite some time. Yeah. Okay. So this method that I'm going to share with you is called Alpashruti method. Now, why is it called Alpashruti? What is the meaning of that? I don't think we will have time to discuss all that, but let me just share the method with you. Okay. We are starting from 1 to 9. The rule is you place 1 in the top row middle cell. Okay. And then you go, always follow this direction. Okay. This is like how you do a J, with right hand you do a J. How does your hand go? Top diagonal left, right? I mean, if you are a right-handed person, J. So from 1 you do a J, you get to this place. But this place is outside the box. So if it is outside the box, what you do is, okay, if anyone has a question, please do a raise hand and I'll call out your name. Suppose that is going outside the box, you imagine a square sitting on top of your existing square, and you imagine what will be the position of that particular cell. So this will be third row, last column. Okay. So third row, last column in this particular square is this. So here you need to place a 2. Okay. And then again you do a J. So the next place is here. Again, you imagine there is a square sitting over here. And this would be the which row, which cell? Somebody?
Sir, the leftmost row and the middle box.
You mean the second row? First
In the
cell.
leftmost box.
Yeah. So row is always horizontal. Column is vertical. Okay. So
yeah.
this is this place. So here you place a 3. Okay. Again, you do a J. You do a J. Now what has happened? There is already a number sitting in the place of 1. So you cannot push that 1 away. So what you will do is it's like you do a J and your hand has hit the wall. What do you do? Ah, ooh. You put your hand down, right? If you hit something, ah. So then you put it right below that number. Okay, 4. Oh no, not below 1. Actually, you put below 3 because this is where you are. Your hand hit that and you're putting it below 4. And then you do a J again. The middle cell is 5. You do a J again. This is 6. Now you do a J. Okay. So just look at this. Now imagine a square over here. Okay. And this place. So you see this one can be a little tricky, but if you look carefully, it is the bottom row, first column. See bottom row,
So
first column.
how do we
Yeah.
know where to construct the square?
Yeah, so that is something that you will have to look. So where is this thing pointing? So this is pointed here. So you need to probably imagine something like this.
So
That
like we
this
can
is
also
a
construct. Okay.
so
There's somewhat a Sudoku.
yeah, I mean you can think of a bigger grid, maybe like a 9x9 Sudoku, and this is the central part, you see. So now you'll have to see where is the arrow going. The arrow is going out into this part. So there you need to construct a square.
You have to start with 1 and go to 9. And will this work for 4x4 grid and
We
all?
will see. We will see. We will take baby steps. Let us first digest this and then we will go to the next one. So from 6, when you do a J, what is happening is it is going to a cell where there is already a number 4 because it is the bottom row, first cell. So again, your hand has hit a wall. So you put it below 6, which is 7. And from 7, you do a J. So now it is here. That cell you check is the first row, first cell. Oh, that one's empty. So I can write a 8 there. Now from 8, I do a J. So I get this cell, right? Which is the last row, middle cell. Oh, that is empty. So it is a 9. Now let me write this 8, 1, 6, 3, 5, 7, 4, 9, 2. Okay. And if you add these numbers vertically, horizontally, or diagonally, it will give you the total 15. Okay, you can check this. Until then, let me just take Agnay's question. Agnay, you have a question?
Sir, I had just joined like when you had started it. So what is the magic square? How does it?
Go through the recording, follow whatever you can from this, and then come back to the recording because we just have little time. There are people who joined late, but if I keep repeating for them, everybody, then it is going to eat up everyone's time. Just watch
Okay,
the
sir.
recording. Yeah.
Okay, sir.
Saket Ram, you had a question. Your hand is raised. No.
Oh,
Okay. All right.
So it's fine. Who told that we can take questions later?
Yeah. Sure. Okay. All right. So this is how we construct a 3x3 magic square, or one of the ways, or the way that we call as Alpha Shuddhi. So I want everyone to get a hang of it. So what I'm going to do is I'm going to give you a set of numbers. Let's take maybe the table of 5, let us say. Okay. So 5 to 45, right? Because 5 ones are to 5 nines are. Can you follow this algorithm and place 5 to 45 in this and check whether you are getting a magic square?
5 should start with the first row middle cell.
That's correct. Top row, middle cell. If you want, you can just take a screenshot of this. I'm going to stop screen sharing. But don't just follow or look at this blindly and do. Try to use the algorithm on your own so that.
Sir, I don't understand what you mean by 5 to 45.
What do you mean by, sorry, 5 to 45? Instead of 1 to 9, we are taking multiples of 5 to construct a magic square. So these are the numbers that we are going to use. And we are going to follow this algorithm. Start with the top row, middle cell, and then you do a J. So what will happen after that, and so on. Okay. Got it, Agnay?
We write it in the chat.
Yes, sir.
No, you don't have to write anything. Once you are done, just message me that you are done. Okay. All right. I see a lot of videos off. I prefer to see people's faces so that I can remember
So
you.
my connectivity is a bit bad, so sorry, sir.
Yeah. That's all right. So
sir,
anyone whose connection is low, that is fine.
Sir, we can
Yeah.
start from any square, right?
No, the first rule is top row, middle cell. Top row, middle cell.
Sir,
Okay. Yes, Aitreya.
sir, can we start from any number or should we start from the first number given?
Top row, middle cell. I mean, any number meaning?
Sir, like suppose you are giving consecutive numbers starting from 1 to 9. So can we start from 6 or 7?
Oh, that's a great question. No, you cannot. Start with the first number. Okay. I'll do one thing. I'll write the, or rather share my screen, which has the procedure. Okay. So this is start by writing 1 in the top row, middle cell. So by 1, I mean the first number.
I'm certain.
Okay. For the next number, go to the right upper diagonal square. So this is where you do this J.
Sir, but if you have to start in the top row and middle column, then there will be
Middle
only
cell.
middle cell. There will be only one unique possibility, right?
That's a great comment. I'll reply to that in the next 15 minutes. That's a great
if
comment.
it works for 4x4 and 5x5, then it will be good. But will it work
No.
for 4x4,
This is
5x5?
Hanuman jump. We are not taking that jump. We will see 4x4, 5x5. But after we are done with 3x3. Okay. Right. Oops. Yeah. So there are 3 simple steps. Start with the top row, middle cell. For the next number, go to the right upper diagonal square. If there exists already a number in the cell, write the next number below the present cell. So something like this. That is, you start like this, 1, you do a J. So that means in this case, we will start with a 5, you do a J. and the next position is this, but this is the bottom row next cell. I mean, bottom row last cell. So you'll be writing your 10 here. Again, from this, you do a J. So this is your middle row first cell. So you write your 15 there. And then again, you do a J from there. That is like this, but there is a 5 sitting over there. So what do? You write it below 3. Suraj, are you keeping a check on the waiting room participants? Suraj? Suraj,
Sir.
are you there?
Just a spacing problem.
Sorry?
No, I am here. I'm adding them.
Yeah. I mean, let it be quick because I see people in the waiting room for a few seconds. Let them join immediately. Okay.
Sir.
Yes, Saket.
So this seems symmetric. So can you start with the J in the left left hand and do everything left hand, because
Yeah. So
reverse.
yeah. So what about left-handers? If you want to do a J to the left, actually you can tweak the algorithm. You can do a J to the left. What will happen? The end result will be, if you do it properly, the end result will be, it's a mirror image of the current magic square, right? It will be, the next number is going to be 15. Below that is 20. You do a J 25. You do a J 30. Now from 30, you do a J like this. So this is going to be 35, which is this identifying this part. No, this can be a little tricky sometimes for some of us when we are doing it for the first time, but I think eventually we'll get it. So this is going to be 40. You do a J again. This place is going to be 45 and then 50. So it will be something like 5, 10, 15, 20, 25, 30, 35, 40, 45. When you add everything, the numbers in all the row, columns and everything, it is going to be, the total is 75. 75. Okay. All right. So what I will do is I'll share these slides with you so that you can go through it. In case somebody is not clear, you can take your time and go through it. So coming to a few questions, that is, first starting with Saket's question, if you follow this algorithm, there will be a unique magic square, right? Yes, there will be a unique magic square. In fact, you can take its mirror image or you can turn it upside down, right? And then flip it. So you can create all this, or maybe you can rotate it by 90 degrees. So if you rotate it by 90 degrees, maybe your square will look something like this. Sorry, your 1 is here, 7 is here, 9 is here, and 3 is here, right? And 2 is going to be here, probably. And 5, 7, 5 is here, and then 2, 5, 8. And this is going to be 4, and this is going to be 6, right? And if you add the rows, columns, and diagonals, it will still be 15. Okay, but it will be a rotational image or things like that. Okay. All right. Yes, Aitreya, question?
No, sir. Sir, I observed that in this one, there is, sir, like 1, 3, 5, 7, 9, and then 2, 4, 6, 8. It's like a type of.
A type of Z.
Yes, sir.
So nice. I never saw this in my life. I've been seeing magic square since many years. I never saw this in my life. I think that's a great observation. Okay. Can I see a show of hands? If you can, you do a raise hand if you think you are clear with a 3x3 magic square construction. I'll feel a little more comfortable and I can go to a 5x5 and then come to a 4x4. Okay. I can see 9, 10 of you have raised hands. Right. Yes. Agnay, I saw your message. Yes, you can. So about 50%. Fine. So others, if you are still having some doubt, don't worry about it. Just go through the recording again and you see the slides that I'm going to share with you. Okay. Okay. So let's go to a 5x5. Okay. 5x5. magic square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It will be easier if you have a square line book, or otherwise you can draw lines miserably like how I'm drawing. And in a 5 by 5, you will have numbers. Let's say that we use 1 to 25. Okay. 1 to 25 is what we are using. Again, for 5 by 5, there are multiple ways to do that. There are many techniques to do 5 by 5. We will be first looking at something, again, Alpashruti method. Okay. We'll be doing that. So the rule is the same as 3 by 3. No change. What is the first rule? Step number 1, start with the top row middle cell. You write a 1. Okay. And then go diagonally up, do a J. Okay. Where will 2 be? Can you tell me which row, which column?
Sir, fifth row, fourth column.
This is row number 5. This is column number 4. It is going to be here. So 2 is going to be here. So if you understand the method for 3 by 3, 5 by 5 is exactly the same. You write a 2 here, you do a J. Can I place a 3 here? Safe, no problem. Okay. I do a J again, 4. Now 4 has gone out of the box. So you need to do an out of the box thinking. You need to imagine a box here. Okay. Oops. Yeah. And imagine there is a column here. Imagine there are rows here. See? So it is this place. Which means
It is the same line at the end of it.
Yeah. So third row, first cell. So this is going to be 4. You do a J up. You get a 5. You do a J. Ouch! You have hit your hand. What do? Shake it and then put it down. Okay. So 5, below 5 is going to be 6.
Sir, below 4, remember last time you told?
No, below the same square. Because from 5 you are going further. You are hitting the wall. Okay. So let me take you through.
So then in your solution in the PPT, then
Okay, wait. Look. 1, do a J. 2, do a J. 3, do a J. From 3 to 1, it is hitting the wall. So the next one, 4, we are writing below 3. Right? Because 3 was the last number. So now, why we are writing below? Are you clear, Saket?
Oh, okay. Sorry. I thought you were saying 4.
Yeah, that's okay. So do ask if something is not clear, okay? And from 6, can you try to extend on your own? Try to complete this. Okay. So those who have finished, I want answer to a question in the chat. I want to know what will be the number in this cell. Send the answer in the chat, okay? For those who finished the square, tell me the answer in this cell in the chat.
Which cell?
AA, where I have written A. Okay. Right. Okay.
Percent.
Yeah, I'm just reading the chat. Okay. Shayon and Johan, you guys are close, but not exactly there. Others, those who have shared so far, their answers are correct. I got a message. I joined a little late. Don't worry, go through the recording again, and then you'll get a hang of it. And those who finished 5 by 5, if you are a little ambitious, can you try a 7 by 7 magic square? The rule stays the same, okay?
Sir, for every odd number.
For every odd number, you can use this algorithm and it will work.
Sir, I sent my answer for it.
Who is that? Yeah, the second one is correct.
Yeah.
Jahan, you are correct now. Shayan, you are still close. I think this, after this cell is where people are slipping. Aitreya?
Sir, the 7
One
by
second,
7
one by one.
cell-
First, Aitreya. I don't have the ability to listen to two people at the same time. So first, Aitreya finish and then Agni.
Sir, if the cell is occupied, what should we do, sir?
We do ouch and we put our hand down. So if wherever you have put the last number, below that you put the next number. Agni?
Sir, so the 7 by 7 is 1 to 49, right?
You tell me.
Yeah.
Sir, can you put the rules on the screen?
Screen. Yes, I can do that. Let me just go here. Sup. Yes. These are the three rules. Remember, this algorithm is for an odd order magic square. So order means how many rows and how many columns will be there. You cannot do this for even order for the simple reason that there is no middle cell in an even order magic square.
Sir, I'm done with the 7 by 7.
So me also.
Oh, so nice. Okay. So let me do one thing. I'm assigning people to breakout rooms and you guys can quickly go to the breakout room and discuss 5 by 5. Just 5 by 5, not
Yes,
7 by 7. So what I want you guys to do is if you are in a breakout room and one of you can share your screen, right? And write, or maybe if you have an Excel sheet, spreadsheet, it is easier to type in, right? Instead of writing and drawing those lines, you can make life much simple. Okay. And remember, you will have just 5 minutes to do this exercise. Okay.
Sir, can you check my?
Wait. Okay. So all of you, I am putting it into breakout rooms where you are supposed to discuss the solution for a 5 by 5 magic square. Okay. And I'll put something in the chat and you can use that for checking your answer or whatever. Is it clear what you're supposed to do in a 5 by 5 in the breakout room? And then we will come again back to the main session. I'll give you another problem Then you go back to the breakout room and you can solve it. Okay.
Sir, I sent my answer.
Can you take my answer?
Yeah. No, I won't check anybody's answers now. Now join the breakout rooms quickly. And if anybody has doubt, help them. If you have understood it, if somebody is not clear, please get all those things clarified in the breakout room. Okay. Quickly join. Come on, come on, come on. Rahul, let me put you into a breakout room. There you go. Right. Okay. Any other observations that you guys made in a 5x5 magic square? Anything else in specific? Any other observations? Yeah, Johan?
Not really.
Okay. Can you look at the numbers
Sure.
after which you are jumping down to the next cell? Is there any specific thing about the numbers? Yes, Shivansh?
So, like, I figured something that
Mhm,
the Z direction diagonal
mhm.
consists of consecutive numbers.
Oh, yes, the J direction, the diagonal or the diagonal that goes from bottom right to top up,
Yes,
that
sir.
has all consecutive numbers.
Yes,
Excellent.
sir. So
Yes,
that is
sir.
why we discover that the magic sum will be the middle number multiplied by 5.
Yes, sir.
Oh, it works here as well. The middle number, in this case, the middle number is 13. So 13 multiplied by
Multiplied by
5.
5 because it's 11, 12, 13, 14, 15, 13 is average.
Okay. Nidhi, you had something to share, Nidhi?
Sir, I was going to say that same thing, middle number multiplied by
Oh,
Sir,
yes, Aitreya.
sir, can you tell me what were you like explaining, discussing now because we were in the breakout room.
Oh, that was top secret. I can't reveal it to you. I'm just joking. So that was, I was just asking if anybody has found any other observation, any interesting observation in a 5x5 and 7x7. So, all right. So I hope at least in some rooms they were able to discuss how a 5, or get it clarified. Maybe we can extend this. You can make, even a 19 by 19 or 41 by 41. You can extend this and create bigger and bigger magic square. Okay. But now let us just take a different algorithm. This is for, again, an odd order magic square. So order is this number of rows or columns. So if it is 5x5, it is called order 5 magic square. Okay. Order 5 magic square. So the algorithm that I'm going to share again is applicable for odd order magic square. Okay, odd order magic square. And this method is called Turaga Gati. Okay, Turaga Gati, it's a Sanskrit word. Anyone knows the meaning of Turaga? No?
Sir, I chose Sanskrit, but I don't know.
Turaga
I
is a
think
horse.
I think the second word means speed.
Gati means speed, movement, motion.
Power?
Sir, I thought horses Ashvaha.
So yes, something can have multiple, it is synonyms. Ashwaha, Turaga, all horses. Yes, Agne?
Sir, doesn't it mean like how fast it's going?
Yeah, so this is actually, there is some kind of horse movement, or the knights move in chess. Okay. So if you know a knight, the horse, how it moves in chess, like a L-shaped
sir.
thing.
L-shape.
Yeah. Like an
Yeah.
L-shaped move. Then,
4 squares.
right. So now in this algorithm, in Turagagati algorithm, you can start from any square. Okay. So it does not limit you to the top row middle cell. You can start from any square. So you pick a square and I will start from that.
Sir, the downmost square,
Down
because it is-
right corner. Down right corner.
Yes, sir. Yes, sir.
Okay,
Sir,
I will
because we
start.
are extending without
Okay.
any
Now look carefully. I'm not going to explain the process to you. I want you to observe and try to figure out the process on your own. Okay, no explanation. So I'm going to put everybody on mute. I'm going on a dictator mode. Put everyone on mute so you can't unmute yourself, which means you will be forced to keep quiet and observe. Okay, now look. Okay, I'm done. All right, so let me see a show of hands. Raise your hand if you think you understood the process and you can construct a 5x5 magic square like this using Turagagati. Right? Keep your hand raised. Keep your hand raised. Okay. So those who have not followed, don't worry, I'll explain it for you again. So there is one thing that we observe. The knight's move that we are following is like this, right? Any knight's move that you are taking is NL like this. But you can change the direction also. Not whenever you want. Before you start, you can decide. Suppose you want to choose this direction as L. Okay. Or this horse move. I hope everybody is looking at the screen. And suppose you are starting from here. Then you can do this. 2. But keep continuing the same move or same direction. Don't change it. First you do this, then you do this. No, you have to select one move and go in that order only. So from 3 again, when you go here, 4, 4 again, you go here, becomes 5, 5 again, you go here. There is a 1 sitting over there. So now what do we do? There could be a question. Should we go down? Should we go up? Those things you will have to figure out. Okay. That is because we are going down now. If you hit a wall, should we write 6 here or should we write 6 above 5? It's something that I leave you for experimentation. This I'm saying for those of you who have raised hand, who feel that they have understood this process. But before they do this experimentation, what I want them, the ones who have raised hand, to do is let me also ask Suraj to, or maybe I'll create a breakout room where I'll put you guys. Okay, those Suraj, can you do that for me? Can you put these guys, those who have raised hand, into one single breakout room so that they can break their heads together? And in that breakout room, I want all of you who have understood to start from this cell and go in this direction. Okay, this cell and go in this direction. Okay, but keep your hands raised. Saket, you had a question? And Suraj, by the way, are you putting them into a breakout room, Suraj? Suraj, can you give me a
Yes,
confirmation?
I'm putting in the room 7.
Room 7. All right. Okay. Yes, Saket, what's your question?
Yes, sir. So my question is, imagine you start from row 5 and column 2. Okay, so imagine you're starting from row 5, column 2. So just put a dot on that.
Okay.
And you go in that direction. That means the middle
upright.
number will be 2.
Yeah.
But that means the magic sum of a 5 by 5 would be 2 multiplied by 5, which is 10.
No, that means your theory that the central number times 5 is a magic constant is wrong.
It only works for that method, not this method.
Does this apply for 3 by 3?
Well, I leave it for you to experiment. Why
Because
do you think I started from a 5 by 5? Right?
Because if it applies for 3 by 3, I know like it's proven by everyone that all magic squares, the middle number multiplied by 3 will be the magic sum.
Who proved it? Hello, people just stated it. Nobody proved anything. They said it is like this. Why Veda Vakyam? You don't question, you accept it. No, so this central number times 3 or times 5 will give the magic constant. Works in some cases, not all. It works when we are using the Alpashruti algorithm. It need not work when we are using some other algorithm. Okay. Is that good, Saket? Yeah, all right, good. Okay. All right. So all of you, Suraj has the room been clear. Others stay in this room, okay? Others don't join the breakout room. I'm going to explain this again. Okay, don't join the breakout room.
Others as in who didn't raise hand?
Yeah, who didn't raise hand, don't join the breakout room. Just stay here. Okay. Suraj, I am not sure if there was a room 7. I think only 3 people have been assigned to room 7. Can you?
I'm assigning
Suraj?
them.
Yeah. You know who are they? Who needs to be assigned to room number 7, Suraj?
Actually, there were only 14 hands. I assigned them, but I think
No. So let me do one thing. Let me just close the breakout rooms.
Sir, I raised my hand, but I am not in the breakout room.
I'm
Yeah.
doing that.
1 second. So Suraj, what you can do is you can recreate breakout rooms. Okay. Instead of assigning them, just do a recreate and put all these guys there. All right. So let me during that time, let me just explain the rule once again. So may I know how many of you put in the chat? If you don't know how the horse move is or how the knight's move is, can you just put that in the chat that I don't know how a horse moves? in a chess, in chess. So then I can explain that. Otherwise, I'll assume that you all know how a knight moves in chess. Okay, nobody has put anything. All right. Yes. Okay, so I'll start from here. Let me start from here. So what is happening is, if you put a 1 here, if you put a 1 here, you are going in this direction. So now you have a 2 here. So, and I think until this, there is no problem. Somebody is on unmute. I think you need to put yourself on mute. There is, yeah, I think I have done that. Okay, 2. So from 2, things can be a little tricky, and you have to have a wider imagination. Okay. Because now what happens is you are going 2 steps up and 1 step right. 2 steps up and 1 step right. Okay, 2 steps up and 1 step right. So that is this cell. But you remember, this is the last row. This is the second last row. And this is the 4th column. So it's going to be here. So this is my 3. See if you have got your 3 correct. Again, 2 steps up, 1 step right is my 4. 2 steps up, 1 step right. Now it is in this way. This is your 5. Naitik question? No, right? Okay, okay. So all of you who had got the answer, who could make this 5 by 5 square, you can check it now. You can stay here. Suraj will create the breakout rooms. I'll give you another problem, and then you can go into that breakout room and discuss. Okay. So after 5, I go 2 steps up, 1 step right. There is a 1 sitting over there. So I will have to write the next number below 5, which is 6 here. Again, I go 2 steps up, 1 step right. So it is my second last row, second column. Second last row, second column. Okay. And then there I write 7. Again, I go 2 steps up, 1 step right. You get 8. 2 steps up, 1 step right. I get a 9. But 9 is here, remember. Last row, 4th cell. This is my 9. Again, go 2 steps up, 1 step right, which is my 10. So far, so good. 2 steps up, 1 step right. Uh-oh, now we have outside of the box. But you see, this is this sweet little place, which is the top row, first cell. But there is a 6 sitting over there. Actually, if you look at it carefully, see, from 5 to 1, when you went, there was a number 1 sitting over there. From 10, when you go into the next number, there is a number sitting over there, right? Just remember this. So below 10, you write 11, you do an L shape, which is 12 here. Again, you do a L shape, you get a 13. Again, you do a L shape, you get a 14. Again, you do a L shape, you get 15. Now again, you will find there is a number sitting over there, right? 11. So below 15, you write 16. You see? Below 15, we write 16. And 17 is going to, 17 is going to come here. So 17 and 18 is going to be here. 19 is going to be here. 20 is going to be here. 21. You see, from 20 to 16, there is 16 over here, so 21. Can you observe which are the cases where we have to write a number below? Can somebody tell me? Unmute and say.
So can I say?
Who is that?
Ahan.
Ahan, yes.
So after every multiple of 5, like we have one which is not fitting.
After every multiple of 5. And why do you think this is happening? Why is it a multiple of 5? Why not some other multiple? Multiple of something else, I mean.
Sir, I guess this is because the box we are using is a 5x5.
Exactly. We are using a 5x5 square. So here, after every multiple of 5, you will encounter this. And for a 3x3, after every multiple of, and if you take 7x7, after every multiple of 7.
So can you repeat? So what is special about all these multiples of 5?
Because it is a 5x5 magic square, after these multiples of 5, we see that we have to write the next number below them. So after 5 multiples of 5, you hit a wall. In 7x7, after multiples of 7, you hit a wall. Something like that.
Okay, thank you, sir.
Okay, welcome. Can you put in the chat now if you have understood or not understood? Just write understood or not understood. Okay, the process. Just put that in the chat so that I know whether you have understood the Turagagati, knight's move. Okay, so one of you said just a bit confused about multiple of 5. Don't worry, just keep observing. So one thing that we need to do in magic squares is keep observing, and you'll see patterns coming out in that particular method. In fact, this method that I'm sharing with you, this is not something that I learned from a book or something. I mean, this method existed in a book, but I did not happen to read that. But I was doing a session like this in another camp, and a student observed. I just gave a magic square, something like this, and a student observed this pattern of horses jumping. So she said, "Oh, maybe there is a horse move jump involved." And that's how I first learned it. Later on, I found out that it was a rediscovery. It was discovered by somebody else earlier, and she happened to rediscover that. So she was very good in pattern observation. And now that girl, I mean, she's she's much older than you. She's happily married. She is working as an analyst. So she looks at data, huge, large data, and then she does some analysis to on them for some banks and things like that. So this pattern
yeah,
observation, this skill,
when you check
yeah,
for
she,
fraud because something is
yeah,
suspicious.
yeah. So she is a data analyst. All right. Okay. So now once others come back, what I'm happy to see that almost all of you have understood it. In case you have a confusion, you can go through the recording again and you will get it. Let me now, would you guys mind if I extend the class by say 15 minutes or so? Will that be okay for you?
It's okay, sir.
Okay. All right. In case somebody has something urgent to do after the class and you have to leave, you can do that. You just go through the session recording. Okay. All right. So just to summarize, what have we seen so far? We have seen Alpashruti method, which is like the Jai method. Second is we have seen Turagagati, which is the horse move. And both these methods we have seen for odd order magic squares. Okay, odd order magic squares. So I have 2 sessions on magic squares. One session, that is today's session, I thought we will do procedures for constructing odd order magic squares and 4x4 magic squares. Okay. And next session, we will do more of problem solving, problems based on these. So when you come for the next session, you all should be good with these algorithms to construct magic squares, because then you can solve problems on magic squares. Okay. There are also methods to construct 6x6 and 10x10 and so on and so forth. But I don't think we will have time to discuss that in these sessions. Maybe for at some other point we can discuss that. Okay. So yeah, so here is a quick run through. One way of classifying magic squares are odd order and even order magic squares. And in even order, there are two types. One is called doubly even, the other is called singly even. These are fancy names that people give. So what does doubly even and singly even mean? Doubly even means it has to be a multiple of the number of rows and columns should be a multiple of 4. And singly even means it has to be a multiple of 2, but not a multiple of 4. Means you can have a 6 by 6, you can have a 10 by 10, you can have a 14 by 14, and so on. Okay, that is doubly, singly even. Doubly even is multiple and 4 by 4, or you can have a 8 by 8 or 12 by 12, and so on. Okay. All right. Another way of classifying magic squares is based on the numbers in it. So there are regular magic squares, which start from 1 and go all the way to, take successive numbers, like what Aitreya had shared. No, not Aitreya, because she had shared about odd numbers, right? So odd numbers don't come under regular magic squares. Okay.
So we
And
can also do to consecutive numbers and consecutive even numbers.
yes. So if you are starting with 1 and going all the way up to a certain number, they are called regular magic squares. Partly regular means you go continuous, but you don't start with the 1. You start with some other number, but you go continuous. Okay. Irregular magic squares are not actually random numbers, but they are not consecutive. Okay. And here Saket had asked one question: can we take non-consecutive numbers? So suppose you want to make a even, 3 by 3 magic square. Here, actually, I'm using something called as arithmetic progression. Have you guys learned arithmetic progression? Arithmetic progressions are sequences where the difference is the same. So I've used 3 such sequences or 3 such APs, short form of arithmetic progressions, which have the same common difference. Okay, same common difference. And what is also interesting is that the first term in those APs are also arithmetic progressions. 1, 4, 7 is an arithmetic progression. So if you take 3 arithmetic progressions, let me take something like 3, 11, and 3 plus 8, and this is 19. And suppose I take, for instance,
All the rows
say
and
plus
are
6.
arithmetic progression here.
6, 9. Yeah, you are correct. Somebody said all the columns are in arithmetic progression. Yes. 9 plus 8 is 17. Plus 8 is 25. Here the difference is 6. So here also, if the difference is 6, it will be 15 plus 8, 23 plus 8, 31.
The
Okay.
diagonals also.
No. This is not a magic square. I have just taken 3 arithmetic.
Diagonals are also in arithmetic progression.
Yeah, correct.
4, 5
So this
plus
is
9.
AP number 1, AP number 2, and AP number 3. So now what you need to do is treat these numbers as 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, which means I will start with a 3 first, do a J, write 11 next, do a J, write a 19, do a J, write a 9, do a J, 17, 25, 15, 23, 31. Okay. Now I look at the magic total. 23 plus 3 is 26. 26 plus 25 is 51. The next row, 36, 51, 40, 51. 51, 51, 51, 51, 51. And it also happens to be thrice the middle number, right? Thrice the central number. So Saket, the answer to your question is you can construct a magic square with numbers that are not consecutive, but if you want to construct a 3 by 3 magic square, they have to be 3 arithmetic progressions with the same common difference, and the first term in the arithmetic progressions also have to be in an arithmetic progression. You get my statement, Saket?
Okay, yes, sir.
Yeah. So if you guys are more interested, I can share an article that I had written on magic squares. In fact, an article on prime number magic square. Magic squares with only prime numbers. You think that is possible to create a magic square with just prime numbers?
Yes, sir.
How do you know?
Twin primes probably. Their common difference is 2. Can do like that.
Yeah, but then the third one should also be a prime, no? Because if you are taking common difference 2, then the next common difference should also be 2. So I think 3, 5, and 7 are the only 3 primes which happen to be in an arithmetic progression with a
Yeah.
common difference 2. Right? So think about it. Is it possible to create? In fact,
So there's
this
not
was
only the arithmetic progression one here, 3, 9, and 15. It has an arithmetic progression of 6. You've written there's 6, 6, 6 for each arithmetic progression. Does it all
I think
have to
that's
be
an
same?
excellent observation. So you can write them in this way also. 11, 17, and 25. Sorry, 23. And 19, 25, and 31.
Sir,
And
doesn't that mean
just 1 second, Agne, let me just complete. So if you take it this way, and if you write, if you do the J method, and if you write 3, 9, 15, and then you look at 11, 17, 23, and 19, 25, and 31, is it the same as this one, or is it different?
It's mirrored.
That is mirror image.
it is?
Yes, sir. It's
It's a
rotated.
mirror image, right? Yeah.
It's rotated.
Sir, that means, sir, what that
Sir,
means?
sir,
J with the left hand. So J with the left hand, it will come. Sir, try that. J with the left hand. Sir, try.
Yeah, yeah. Correct. Yeah.
It has
The whoever,
rotated to 90 degrees.
yeah. Not 90 actually. It is kind of a flip. It's a mirror image. It's like you have kept a mirror here and you are seeing the
Like
image, mirror image.
rotated 180 degrees.
I don't think it is even rotating, because rotating 180 means the 3 above will come in the bottom row, no? That is our rotation of,
Yeah.
yeah.
Yeah, it will be simple flipping.
Yeah, it's a flipping. It's a flipping. Okay. All right, your videos have gone up, so I'll get bored if I just talk to myself. Can you keep your videos on? Yes. All right, so let's get into the exciting 4x4 magic squares. Okay, 4x4
Can I
magic.
show something?
Yeah, you made something.
No, not made. I was learning about it.
Okay. Can we
Magic
do that after
squares
the
only.
session? Is it okay? Can we do that after?
Yes,
I want
sir.
to see what. Okay. Thank you, Shrestha. So 4x4 magic squares, you have to pay close attention to this. Okay. Close attention to 4x4. There are many algorithms for 4x4, mostly based on patterns. But you need to observe the pattern carefully. Okay. So this one that we are going to do is, let's call it as Duragati with a jump. Okay. With a jump. Okay. So here also you can start from any cell.
Turagati.
Sorry, say that.
Is
Oh,
it
I missed
Turagati or yeah.
Turaga Gati. Yeah, thank you for the correction. Okay, so you can start from any cell. Let's say that I start from here. This is 1. Okay, from 1, I make a horse move to any direction. Let's say that I make it to this direction. I write a 2 here. And then you need to take a jump. Write my 3 here. Skip a cell and jump. Okay, skip a row actually and jump. And then I go back here. So this is my 4. Let me give another starting and placement. Wait. Questions later. 1 second. Suppose I start from here again and I do a horse move like this. Let's say 2. My jump will be here. My 4 is going to be here. Suppose I start from a different place. Let's say I start from here 1. I take the horse move, let's say here 2. I skip a cell and jump, which means I'm going to be here 3. And I went down in this direction, so I will go up in this direction. So my 4 is here.
You're technically rotating it, sir.
Let me keep doing this. Suppose I start from here and I take a horse move here, skip a cell, jump, come back here. So the fortunate or unfortunate thing about patterns is you cannot explain. You have to see it. So I can only draw. You will have to see that pattern and see how that might be working. So I put a 1 here. There is my 2. Skip a cell, jump, which is my 3 here. And my 4 is going to come. So 1 went here. Let me see a show of hands. If you understood how to place 1, 2, 3, 4. Just do a raise hand if you understood how to place 1, 2, 3, 4. Right? Keep your hands that way. If anybody has not followed, can you unmute and say which is the part that you have not followed? And I can explain that. Nobody? Others? I think around 10 people have not raised hand. I hope you are not sleeping. It's Sunday afternoon. That's what most most people do. All right. So I assume that everybody has got it. Okay, great. Now for 5, 6, 7, 8. Okay. 5, 6, and look carefully. Look very carefully. See, the way I have placed 1, 2, 3, and 4 is such that 2 rows contain 2 numbers. If that happens, then 2 rows contain no numbers. Or if 2 columns contain 2 numbers, then 2 columns do not contain any number. Okay. So it is in some way like that. Now what I'm going to do is I'm going to pair 5 with 4, 6 with 3, 7 with 2, and 8 with 1. But I'm going to pair them intelligently. I'm going to pair 8 here, 7 here, 6 here, and 5 here. I'm going to pair 5 here, 6 here, 8 here, 7 here. I can pair 8 here, 7
The
here.
pairs all add up to 9.
They all add up to 9. That's correct. 6 here, 7 here, 8 here, 5 here.
But why are you doing it?
Why am I doing it? Because India is a democratic country. I have the freedom of expression. I have the freedom of speech. No, so there is a reason why I'm doing this. We will see. Let me create another one and let me place 1, 2, 3, 4. And you tell me where to place 5, 6, 7, 8. Okay. Where is? Yes. Let me start from 1, 2, 3, and 4. I'll call out somebody's name. I want them to explain. Vaishnavi. Vaishnavi, can you tell me where to place 5? Yeah, just make a guess. You are on mute, Vaishnavi.
Sir, I don't know.
That's okay. That's okay. Nikhil, you want to give it a try?
Sir, in front of the 4 at the rightmost corner.
You mean here?
Yes.
Can I place it to the left of 4? Nikhil
Sir,
can
that
also say yes. Why not? India is a democratic country. We can place 3. So let's see what will happen if you place 5 to the left of 4. Okay, so we'll do both. And this is what I like about math. We can do safe experiments without killing anybody, right? Worst case scenario, you will have to rub whatever you have written. So I'm going to write one more. Suppose I write 1 here, 2 here. You see, my 1, 2, 3, 4 are in the same places, but I'm trying to write 5 in a different place. Okay. So can I write 5 here? Let us explore all the 3 scenarios. Okay. So this is my scenario 1, this is my scenario 2, this is my scenario 3.
So Saket, I don't understand, sir. How?
Yeah.
How? Why is 3 above? Like if 1 goes like left down, 2, then 2 goes left down. Why is 3 above?
Yeah. So from after 2, we are skipping a cell and writing it below. So 1 to 2, you are coming down. So for 2 to 3, we skip a cell and write below, but this position is this position, Saket. Okay. And we
So,
take the
what do you mean
opposite
skip a
direction.
cell?
Say that again.
Oh, so what do you mean skip a cell here?
So after 2, so what we are doing, we are skipping a cell here, no? From 2, when we go to 3, we are skipping a cell, no?
Yes, sir.
Yeah. So from 2, when we skip a cell right down, 3 is going to be in this place. And then we take the opposite direction that we took for 1 to 2. So all these patterns, no, that if you ask why patterns work, well, there is no explanation to patterns because patterns is something that we observe. Okay. But of course, there can be mathematical proofs to all these things. But right now we'll just get into the fun part, that is the exploration part. All right, so let me, yeah, Nikhil, yeah, I think Nikhil gave an answer.
yes, sir.
Where to put 5? What about the number 7? Nidhi, you want to try in scenario 1? Where will you place 7?
Sir, on the right side of 2.
On the right side of 2?
Yes.
Why did you choose the right side of 2?
So like 5 was placed on the right side of 4.
Ah, I see. So 5 was, so you saw in the previous examples also,
Yes.
if 5 is placed to the right of 4, 6 is placed to the right of 3, 7 is placed to the right of 2, 8 is placed to the right of 1. So it is as though 5 decides where 6, 7, 8 and 6, 7, 8 should be. Right?
Yes.
So 5 is the mother in the house. She will decide what's best
Sir,
food that
one of
everybody
them,
should eat.
sir, if one
Yeah.
of them is placed in the south, then all of them get placed in the south.
Yeah, so if one is placed in the south, then everything gets placed in the south. Okay. All right. So 7 and then 8 will come here and 6 will come. Okay.
Sir, I have a question.
Agnay, yes.
Sir, can I annotate and show you?
Yeah.
Yes, sir. Sir, so when 5 and all these numbers are same throughout,
Yeah.
but here 4 is to the right, 4
Yeah.
is to, sorry,
Oh, no.
5 is to
5
the,
is,
yeah,
sorry. Yeah,
5
go
is
ahead.
to the 5 is to the left, and here 5 is to the right,
Yeah.
here is to the up, 5 is above. When we want to go down, can we write 5 here?
Yeah. So we will see that maybe after this, we can see a scenario 4 there. Okay. So I want somebody else to try, maybe who's there. Naitik, can you tell me in scenario 2, where will you write 7?
Above 5?
You see, when 5 is written to the left of 4, 7 has to come to the left of 2, 8 will come to the left of 1, 6 will come to the left of 3, right? Because the direction is the same. See, when 5 was to the right of 4, 7 was to the right of 2, 6 was to the right of 3, 8 was to the right of 1.
Sir,
Right?
Saket, I'm getting confused, sir.
Very good. From confusions, we get clarity. Go ahead.
So,
What's your confusion?
sir, what are we making right now? So, like, who put 1, 2, 4, and 3 in random places, and then
Oh no, not random. No. So just
it's
be
not
patient.
following the Durga
Don't
Gati.
worry. It is following Turagagati. From 1 to 2 is Turagagati. 3 to 4 is Turagagati. Between 2 and 3, we skip a cell.
So, but if you go, but when you mean you skip two cells?
2 cells. No, from between 2 and 3, there should be an empty cell.
Yeah.
So,
Between 2 and 3, and also one more thing, the direction has also changed.
yeah, so now we have more flexibility. So, Saket, things will start making sense after we finish this. So until then, you'll have to just keep watching as if you are watching a suspense movie. In the climax, you will get, oh wow, this is what was happening.
And sir, in the 5, 6, 7, 8, what are they supposed to, like, why are they to the next to 4, 3, 2, 1?
My answer stays the same. Right now, just be patient, keep observing. Okay, and we will have answers to all of these. So to the left of 2 is 7, but 7 goes outside the box. So 7 will come here if you look at it carefully. You imagine a square here, this position 7 is here. To the left of 1 is 8. To the left of 3 is 6. Sorry, who's that?
Sir, I'm Samrit.
Yes, Amrit.
Sir, so if you take 4, if you take 5 to the left of, if you take 5 to the right of 4 in the situation 1, sir, then you again need to follow a fixed pattern.
Yeah, that is what I said. 5 decides where 6, 7, and 8 will go. Yeah. So this is scenario 2. Now in scenario 3, there is a problem. You know what? Because if 5 goes above 4, then 8 has to go above 1. And 6 has to go above 3. And 7 has to go above 2. Now you see, you have exhausted all the small numbers in the same columns. And this total is 19, this total is, 18 and 18. Now the bigger numbers, when they come in the other columns, you can clearly see that their totals will not be 18. You see? So this is a strict no-no, which means India is a democratic country, but there are rules to follow. You cannot do whatever you want. So here, what the problem was this. When you place 5 above 4, it is also coming in the same line as 1. You see? It's coming in the same line as 1. So if you cannot have numbers coming in the same line like this, especially if it is numbers like 1, 2, 3, 4, 5, 6, 7, 8. And you look at the other arrangements. So this is where you need to intelligently decide where to place. If your 4 is here, you can put a 5 to the left or 5 to the right, no problem. That's what we did here. Here we did to the left. But if you put it up, then all the numbers in the same column will be 1, 2, 8. Okay, so that is not a good idea. Now what do we do? Now the task is very simple. Very, very simple. Now it is just fill in the blank. So once you have got 1, 2, 3, 4, 5, 6, 7, 8, all that you need to remember is this. You have numbers 1, 2, 3, 4, 5, 6, 7, 8. The next numbers are 9, 10, 11, 12, 13, 14, 15, 16, right? Because it is obviously a 4 by 4. Now 8 and 9 you need to pair. 7 and 10 you need to pair. 6 and 11 you need to pair. 5 and 12. In other words, a number, if you want to find the pair of 4, you don't have to write the entire sequence. You just have to do 17 minus 4 is 13. So that's its pair. If you want to find the pair of 16, you need to do 17 minus 16. Its pair is 1. Okay. So that's how you get these, let's say, the numbers married to each other. Okay. You find their pair. And what do? What you do is you place the pair of 1 in the diagonally alternate cell of 1. This is the diagonally alternate cell. Alternate means you skip something in between. And diagonal. So here you need to place 16. In the diagonally alternate cell, you place the pair of 1. Okay. Sorry, my OneNote is acting funny, but let me just maybe try to write more clearly. Yes. All right. So the diagonally alternate cell of 1, you write the pair of 1, or you ask what added to 1 will give me 17. So you write 16 there. You see a 2, you find diagonally alternate cell of 2 is this cell. There you write the pair of 2, which is 15. You find 3, which is the diagonally alternate cell of 3. It is this cell. What is the pair of 3? 17 minus 3, which is 14. And like that, you fill up the remaining cells. 11, 12, 9. Ta-da! There is your magic square ready. You can try that with this one as well. And let me ask Johan, what do you think will come in this cell?
So I think 15 would come.
15. Sahi jawab. Agnay, what will come in this cell?
Sir, 16.
16. And Raga, what will come in this cell?
$11.
11. Viraj, what will come in this cell? Viraj, you're on mute in case you're saying something.
Sorry, sir. I could not hear the question. Can you
No,
please?
I'm asking what will come in the first row, second cell between
Okay.
1 and 4.
So in the first row, second cell,
Mhm.
maybe 16.
Is that a
It's-
guess?
No, because it's paired with 1. Oh, wait, no, not
No,
16.
it's paired with 3.
Okay, then. Okay, then 18. It's That's what's fit for.
17 minus 3. No, see in the diagonally alternate cell. So what do I mean by diagonally alternate cell? Did you get that diagonally alternate cell? Viraj?
No, sir.
Okay. All right. If you look at the square we just completed, you mean the first square, you see the first square. See where you have 1 and 16. This is what we call as a diagonally alternate cell. You look at 12 and 5, this is diagonally alternate. You take 9 and 8, this is diagonally alternate. And these cells, they add up to 17. Okay, so 10 and 7, they add up to 17. So we are trying to make these add up to 17. So diagonally alternate cell of 3 is 14. I mean, is this cell, so there will be a 14 there. Diagonally alternate of this cell is this cell over here. It's going to be 10 because 10 plus 7 is 17. And this is going to be 13 and this is 12 and this is 9. And you'll see that every row, column or diagonal, can people tell me what is going to be the total of every row, column and diagonal in this?
34.
So 34. So 34.
34, right? So this is a regular 4x4 magic square created using 1 to 16, and the magic constant or magic sum is 34. Okay, 34. Right? We have exhausted the extra time that I asked for. So let me just throw you some questions. I'll put this in the Google Classroom as well, which I'm going to share as homework. I think one of you have gone on unmute. Can you put yourself back on mute? Yeah, all right. So I'm going to give some cases which are, where you need to find missing numbers. So if this is the magic square given, you need to find the missing numbers. Okay. And I will give that in the form of a spreadsheet. So you can check for yourself. If you put the numbers, if the total doesn't come, the total will automatically come. And if it does not match, that means you have gone wrong somewhere. So that way you can check for yourself where you have gone wrong and so on. Okay. And I'm also going to give some challenging questions, which is not compulsory. But if you wish to torture yourself with some extra bit of math, you can go through that. So let us say that I use the numbers 1 to 25 or 1 to 49 or 1 to 36. And I make magic squares of, in this case, 5 by 5, 7 by 7, 6 by 6. And I will say, sir, where did we learn how to construct a 6 by 6 magic square? We have not learned yet. But I'm asking, suppose somebody gives you a method, okay? Can you always find the magic constant? Don't shout the answer and don't send the answer on chat to everybody. Can you always find the magic constant for these? Is the question.
So what is the
In
magic
other words,
constant?
magic constant is the sum of any row, column, or diagonal.
Okay, sir.
Okay. Or it in simple words or in mathematical language, for an n by n magic square, what is the magic constant? That means we are talking about generalizing, or we are trying to create a formula for n by n magic square. Okay, that is what we are looking at. And this is what primarily interests mathematicians. They are not interested in one case, two case, three cases or something. They are interested in a general case. Okay, all right. So my next class is going to be next week. So we'll have enough time to work on this. It's not tomorrow. So I'll share that in the breakout room, but don't leave. I think Shrestha has something to share. Yes, Shrestha, quick.
Sir, is it like I'll show it you 1 second.
Let me spotlight your video so that you can show that on the screen.
Yes, sir. Are these some types of the questions?
I can only see north, east, west. Vimana. Oh, Vishama magic squares. Oh, wow. Narayana Pandit. Oh, wow. Where did you get this book?
I was attending a Vijnana Pravecha series. They
Oh,
gave
this
this
is
book.
Bharatiya Ganita. Oh, so nice. So nice. Very nice. So some of the methods that I have used, no?
There are huge magic squares.
Oh, yes. So there also, I think, can you show the name? There is Abhyasa. Okay, this is the exercise. I see. Nagarjuna's method. Oh, yes.
Excuse me,
Yeah,
you
so
can
what?
share the name of the book in the chat box.
Yeah. So let me find out. I think that book is available for purchase. Is that so? Huh? Reshta? Is that the book?
Yes, sir.
Is the book available for purchase?
I don't know, sir. I think it is there.
Okay.
In Anadi.org.
Sorry, where?
Anadi.org. This is one logic for 4-on-4 magic.
Anadi.org. Is it ANADI or ANAADI?
ANAADI.
I see. Okay, if I find the link, I will share. Otherwise, somebody else also can share this. IKS books. I think. Okay, I'm just looking on the internet. Yes. Okay, I got the link. Let me share it in the chat.
Sir,
So the people
there
who
are
run this.
3 levels.
Yeah. That's correct. Yeah. Yes. So this is the link, and those who are interested, you can share this link. You can open this link that I've shared in the chat, and you can share it with your parents. Okay. So that's all from my end for today. Shrestha, if you can just stay back for 2 minutes, I just wanted to have a quick chat. And others, Tata. I'll see you after a week.
Bye, sir. Thank you.
Bye.
Bye, thank you.